So in the last video, we discussed about how to find area under a curve in an interval, right? What we did is we divided the interval into the many n sub-intervals, n intervals, right? In n pieces, right? And then each of them has width delta x. What we did is we found the lower sum or the left sum by taking the area of each of these pieces by completing the rectangle. We're taking the height on the left side, right? That was denoted by L. And next time what we did is we found the area of these rectangles by taking the right side as the height and complete the rectangle and find the area of each rectangle and add them to find out the area under that. But now what we want to do is, instead of taking the left or right, you can take any point in this piece and then find the height there and then consider that height as the height of the rectangle and find the area of that rectangle. Similarly, you do for each of those pieces. So what should be that point be? That point could be left side or the right side or anything in the middle. Okay, any height you can take that as in the middle. So you find the area of the small stripe here, and then by taking delta x times the height, and then this one will be the delta x times the height, and so on. So we denote that random point where you want to calculate the height as this is C1, and you take another point, take C2, take another point, take C3, and so on. Okay, so let's go on there. Divide the AB in the interval AB into n equal parts with the length delta x equals to b minus a over n. That's the same thing. So pick a point CI in each piece and complete the rectangle with height FCI. So the area of each rectangle is, for this is FC1 times the delta x, this is FC2 times the delta x, this is FC3 times the delta x, and so on. Okay, when delta x is small, when this value is very small, meaning there will be so many of those pieces, right? If that delta x is very small, meaning there will be so many such pieces. What that means, that is where there are many such pieces, that is when n tends to infinity, number of pieces are very big, then the sum of the rectangle approximates the area under the curve. You see that, right? Because here if you approximate with 1 2 3 4 5 maybe 6 rectangles, then you will be missing some of the area there. You see that? But if you take so many such pieces, like many such pieces like this, then the area under the curve and the area of some of the area of the rectangle will be almost the equal. You see that? So in that case, you can approximate the area of the rectangle, area of the sum of the area of the rectangles as the area under the curve y equals to f of x. That's what it's saying. That's why what we write is area A equals to limit n tends to infinity, meaning there are many such stripes. I runs from 1 through n, f of ci times the delta x. This is the area formula now. We call this as the limit definition, area by the limit definition. Okay, we'll do some examples there. Let's do that. Use limit definition to find the area under 25 minus x squared in the interval 1, 4 and above x-axis. So this is that curve in the interval 1 through 4. This is the shaded region. So you are basically finding the area under this curve over x-axis and left of 5 and right of 1. So again, so here what is A? A is 1, right? The left end point of the interval. A is 1. What is B? B is 4. So delta x will be 4 minus 1 over n. That will be 3 over n. That is delta x, right? Each of these have length delta x, that is 3 over n. And Ci is a point in each subsection. So Ci is a point taking at each of the subsections. Okay, at each subsection xi minus 1 minus xi, let us take Ci equals to a plus I delta x. So what you can do is you can pick Ci the left bound or the right bound or anything in the middle. So it is hard to find out which one to pick in the middle, right? That's why what I'm going to do here is To find out the area of this rectangle, I'm picking the CI towards the right endpoint, right, like we did in the right area, right, or the upper area. So I'm trying to do on the right. So which is the right side of the rectangle? That will be A will be 1 plus I times delta x is 3 over n. So I'm picking CI is 1 plus 3 times I is 3i over n. That is my CI. So how do I write this there then? So the area is, I'm using that formula. So delta x times f of CI. So delta x is 3 over n, right, times f of CI is 1 plus 3i over n. You see that? Now let's use that formula. Let me start from the left side here. So limit n tends to infinity. So summation I runs from 1 through n. There is 3 over n. What is f of x? So we have f of x is 25 minus x squared, right? So what will be f of 1 plus 3i over n? So replace x by that, right? So 25 minus 1 plus 3i over n square, right? That's what you get. You see that? So let's plug in that. So you get 25 minus 1 plus 3i over n square and that. You see that? Now we need to FOIL this because there is a square. So what is 1 plus 3i times 1 plus 3i? 1 plus 3i over n times 1 plus 3i over n. You see that? So if you do that, you will get 1 times 1. Oh, I'm sorry. This is just 1 and then plus 3i over n. Okay. So you get 1 plus 3i over n. Okay. If you simplify this, what do you get? You get 1 times 1 is 1 times 1 is 1, right? You do that and then you do the other one, right? So 1 plus 3i over n plus with this one 1 plus, so 3i over n times 1 is 3i over n, and then plus 3i over n times 3i over n is 9i square over n square. You see that? That's what you get. So I'm plugging in that thing there. So you get limit n tends to infinity, summation I runs from 1 through n, right? 3 over n. Now 25 minus, I will have this thing, right? You see that? So what you get basically is 1 plus 6i over n, because 3i over n plus 3i over n, 6i over n, plus 9i square over n square. That's what I get. So but this is inside the parentheses, so you need to distribute that negative sign. You will get negative 1 minus 6i over n minus 9i square. Okay, what do I do after that is basically you distribute this 3 over n to all of them, but before that 25 minus 1 is 24, right? So you distribute that. So you get limit n tends to infinity, and then summation you have 1 through n, right? So I is from 1 through n. You write 25 minus 1 is 24, and times 3 over n is 72 over n, right? And then minus 3 over n times 6i over n, you get 18i over n square, right? And how about the last one? 9i over n square times 3 over n is minus 27i square over n cubed. You see that? Now what you do next is you distribute the summation sign. If you distribute that, you get limit n tends to infinity, and then you do summation 72 over n 1 through n minus 18 over n square summation I, right? And then minus 27 over n cubed summation I square, right? That's what you get. Now the thing is 1 through n, this summation is also 1 through n. So this is constant, n is also constant because I is the variable there. I equals to 1 through n. I is the variable, okay? I are the variable, that's why I kept I inside this sum, but all other things you can pull that outside. You can pull this outside as well. So what is the sum of this constant? It is n times the constant, right? Because we know the formula is summation of C is 1 through n, I runs from 1 through n, is n times c, right? That's why this, the first one, let me write the limit here. Limit n tends to infinity. The first one will be n times this 72 over n, right? Minus 18 over n square. The sum of this will be n times n plus 1 divided by 2, right? And then here minus 27 over n cube. This will be n times n plus 1 times twice n plus 1 divided by 6. I'm using this summation I squared summation I formula from the previous slide. Okay, so after this I want to write here. So let's cancel the things. I am cancelling this. What is left is 72. 72 look at this. The 72 does not have the limit n, right? That's why you don't have to have the limit for this. I will move this limit to the second term. So and the third term, limit n tends to infinity. Since you cancel n and one of the n, so and I want to factor out n from the top. 1 plus 1 over n over there is 1 n left and there is 2 left, so 2n. Similarly, I have to cancel that n with that n. And then what do you get? You divide by 3, 2, 3 will be 9, right? So what I want to do is minus 9 over 2n squared, because one of the n is cancelled out there, right? So how many left is 2 of them left. Now I want to factor out n from here, another n from here. Take out n from here. What is left is, so if you take n out, you will have n squared, because 1 n here times 1 n from here. What is left is you will have 1 plus 1 over n, right? And from here 2 plus 1 over n, right? So and then times 2 plus 1 over n. When you take n from this out, from this one you take n out, from that one you take n out, right? That's what you get. Now take the limit there and then cancel the things, n and cancel n squared and n squared there. So what is left is 72 minus, take the limit. If you take the limit, what do you get? Oh, by the way, I forgot 18 there. So 18n, right? So what you get if you take the limit is this will become 0, right? And then what is left is 18 over 2 and 2, right? So that is also 9. So minus 9 minus. How about here? If you take the limit, this 1 over n becomes 0, because limit is n tends to infinity. This 1 over n becomes 0. What is left is 9 times 2 over 2, right? So 2 and 2 cancel out. So what is left is 9. Okay. So how much is 72 minus 9 is 54. That is the final answer. Thank you, guys.